In this video we're going to flesh out the rest of our demo here in our full stack forms. We've got loading going, adding a little bit of additional, or I've gone ahead and added a number of things. First, let me just show you a few of the fix-ups that I've done just to make things a little cleaner. I removed some of the cruft code. I added a table cell field function. I mentioned something like this in the last video where you could just make a function that would take a lot of the boilerplate out of it, so that in my table now I can say I've got a table cell field for item title with this validation message and this on change, and then all the, all this crap about validation just kind of evaporates. The dropdown didn't have validation, so I didn't bother integrating it because it needed a bit more in terms of options in order to be able to do it. But the three major fields were easy to do that with, and get essentially the exact same result that we already had. So then I went ahead and cleaned up a few other things. So in terms of when to mark these things complete so validation messages show up, obviously the on blur thing seems fine, and you see some row actions appearing out here. So once I've got once I've blurred on something, if it's invalid, that seems like a reasonable time to mark it valid. And I've blurred these now. Let me go to this one and make it negative, right? So you can see that that's negative. Something else that somebody might do is they might press save. So there's a sequence of things that has to happen here where you've got to figure out, when and how to show these validation messages. Fortunately, it's declarative on this side. All you have to do is basically say, if the field is showing up invalid, render its validation message. That's just all there is to it. So there's no logic in the UI, so to speak. There's more logic in the processing as you move through the thing. So we did go ahead and put an on blur on here to mark complete, but let's just take that off for the moment. Let's just make it so that we're not marking fields complete as we go, which means we're not going to get validation errors as we screw things up and blur from field to field, which might be a way you'd like your form to appear. In this case, what we'd like to happen is when we attempt to save, we'd like to see those validation messages show up. So and here the save button has disabled itself. Right, so that's sort of how we typically like forms to behave. So again, this doesn't change in the rendering. We can take this blur out of here and just not worry about the whole does focus work or not on the browser, etc. Kinds of mess that typically plagues people writing browser-based software. So the things that I'm going to add here, couple of UI attributes. So again, these UI namespaced attributes are things that won't be sent to the server on a load. So if I go and reload this and look at my Fulcro network tab, what got sent out for items at ID title, none of those UI things showed up in there. And you can actually extend what it would strip out. So for example, I might want to strip out things that are root queries like this. Fortunately, Pathome tolerates these just fine and just returns, something that's not going to hurt anything. So in this case, I'm not rewriting the middleware to fix that because I don't have to. So I'd like to know when the thing I'm creating is new, because that has a different kind of code path, so to speak, through the logic of the forms than not. And I'd like to know when I'm saving so that I can just show an indication to the user. So I'm going to purposely put a delay in my server-side save just to emulate some latency so we can see that happen. And from here, everything else is as it was in the prior demos and talks. I'm using pre-merge to get the form config, and I've just fixed up these table cells. I moved all of the mutations for the client side into the model item namespace. This is a CLJS file, so these are the client side portions of the mutations. And so we have remove item, is the item valid, etc. I did beef up the item validator just a little bit to catch exceptions. This greater than or equal to math operator, if in stock was an invalid string, was throwing an exception, and in that case it is invalid, but I needed to put this try catch to make that a little more stable. And then I've got some implementation for adding a new item. So there are a couple ways of doing add item. One is to actually write a mutation. And you could, and in fact I did in a prior version, if you go back and look at the other videos, have in here where I just manually created this map, associated into app state. I mean, it sort of looks like, you know, assoc in at item ID, this map, and then etc. Right? Like do the steps. But we saw in prior videos that merge component is really built to do this. But one problem we have here is I can't get to the component that I need through a require, because that would create a circular require. And I can't do that in ClojureScript. Fortunately, Fulcro comes with a central database that components register with when they're used. And you can look up components classes by a keyword that exactly matches their namespace and name, and get back the actual class. So I could make this add new item mutation, use this convenient merge component thing, use the append to plop it onto the end of the list. The problem with this, I don't love this either, is that really this is a thing that's known in the UI call site where I'm adding the new item. So is the ID. I could wrap this whole map thing in a function that like represents a new one. And this path is also a UI specific path. So it doesn't really, like, this is really a localized concern of the list. And that particular list, like this mutation is not going to work anywhere else. So I don't really love that. So what I'm going to do instead is in the client, instead of calling add, I'm going to use merge component directly. So instead of transacting that add new item and then making it like hiding all the details I'm hiding are the details that I only know right here. So I don't want to do that. And that's why merge component exists. Merge component is, yeah, I'm doing some merge of state that's really UI centric, where I want to throw this stuff in and append it to me at this field. Right? So this seems like a much more sane way of doing an add a row. Now there's another thing that I'm doing here, and I am marking this new, but I'm also doing something different here. Before I had random UUID here, and Fulcro supports temp IDs, and this is a huge topic in and of itself. In a lot of my applications I actually use UUIDs period, and that's because I'm using Datomic and can have a UUID identity field. You could use SQL and have a UUID based alternate primary key field or primary key field, and that allows me to do everything I want to do. But a lot of people have databases, they're in SQL, they've got an integer ID, and they need some way to distinguish between an ID the client made up and an ID that needs to be associated with the database. So I'm going to show you this facility of Fulcro while we're at it. So when I add one of these new rows, I'm going to add something that has a Fulcro data type called temp ID, and this is actually a def record. So if you go and look, you know, it's a def type, and there are transit handlers automatically installed in the middleware for the server and the middleware for the client that can handle these. So it'll automatically transmit and receive over the network protocol without a problem, and maintain its type. It'll be a temp ID on the server side too. So that's how we're going to add a row, is we're just going to use merge component. So add a row, I can go look in my database here, and if I look at item ID, I'll see I've now got a Fulcro temp ID with the various things in it. Okay, so now let's talk about the save sequence. So, well, take that back. Let's talk about the undo sequence. So undo has a dependency upon whether or not I'm undoing a change to something like this, and whether I'm undoing an add. And so let's go look at the undo button real quick. It's really straightforward. So undo says, well, if the thing's new, then use this remove item mutation. I don't want to do the bit twiddling here. So remove item is remove the ident from that list and then dissoc the thing from its table. That's really straightforward. And then reset form is part of form state, and all this is it calls the mutation, or it is a mutation reset form, and it just calls pristine to entity, which you saw in a prior video. So those are the two things I can do to implement undo. So you can see it's very simple. The form state's remembering the original pristine state, so I can make all sorts of changes here and hit undo, and everything goes back to the way it was. So really simple to implement that particular functionality, which is nice. Okay, so let's move on to our save here. So there's several things we want to deal with when we're saving a new thing. So first of all, validation. And so when I go to save this, that's when I want the validation to happen. So let's look at our implementation of save. So save calls a mutation called try save item. Now the reason I'm calling it try save item is I'm not actually going to have this part do the remote. I'm going to have this part carry along a diff from dirty fields, which we saw in a prior video. This thing just gives us a calculation of what's dirty on the thing. And this accepts an options map at the end where you can tell it it's new. And when you tell it it's new, it includes all fields no matter whether or not they matched what you started with. So for example, we started with 0 here. If we don't change that, if we didn't say new entities, that in stock field wouldn't appear in the network transmission. So this just makes sure that dirty fields diffing just thinks everything's dirty basically. But it still grabs things recursively. Okay, so try save item. Let's go look at that. So try save item just tries to do some validation. So you can back up the video and look at this. I'm going to go through it rather quickly, but I'm using that trick where I just mentioned a minute ago. I'm using the registry to find the item list item in state. I'm using mark complete to go through and make sure all the fields on the entire form are marked complete. I'm pulling the normalized entity out of its table. So completed state, this is just going to be item, title, item, you know, that limited amount of stuff. And then I'm using db2tree to denormalize it and turn it into a tree. The reason I need that is my item validator works on a tree of props and I'm in normalized state. So that's why I had to grab this this guy. I should reorder that so it's a little more obvious. I need that class to get the query. I could have passed the query as a parameter. That probably would have been cleaner. I wouldn't have had to deal with knowing what class I was dealing with here. But for the moment, let's just call this good enough. I can call my item validator, and then I'm looking for it to be exactly valid. So if it won't be unchecked here because I've marked everything complete. It's either going to be valid or invalid. So if it's valid, then I'm going to proceed on to issuing a transaction that will save the item. And otherwise, if it's not valid, I'm going to reset my entire application database to be this completed state. So basically, I'm just going to run mark complete. I just didn't want to run it again. I mean, I could have said swap, you know, state, mark complete, yada, yada, yada here, but this is just push completed state into the application. That will cause all the fields to be marked complete, which will cause the validation messages to show up. So if I go save here, save isn't actually going to do the network transmission. It's not going to do this transaction. Instead, it's just going to save the completed state into the database, and that's going to cause the mark completes to change the state of the entire application, which will cause these renderers to render their problems. And so now I'm ready. So let's say the thing does validate. If the thing does validate, then I'm going to call the save item transaction with the same parameters that I got here. And remember, what I sent from the UI layer was the item ID. This one's really for convenience. It's actually included in the diff. And the diff. And remember, the diff is just like an ident-based map. The keys are idents. The values are what changed. We'll see this on the network in just a moment. So save item. Let me mention this a second. As your project gets bigger, you want to be able to navigate on these things. And so if your def mutations are showing in yellow, I've said this in prior videos, but I'll say it again, you'll want to grab this little light bulb menu and say resolve that as, and then specify def mutation and find the one that's in Fulcro client mutations. This is the version 2 of these. These are integrated into IntelliJ cursive, but I've not gotten the cursive project to integrate the new namespaces. So you can just pick this. It'll then index them, and then I've got a keyboard shortcut for navigate to the declaration. Mine's Command B. Yours might be something different, and that'll jump me right to the mutation. Oops, helps if I'm on the right symbol. Right, so this is what's letting me go in here and say, oh, I want to jump to remove item. Well, that's just data, but it looks to the ID like a function, so it's indexed, so I can jump to it. So as your project grows, this is a really important facet of being able to deal with the code. You need to be able to navigate it, understand it. There's also a navigate back, which I have set to the normal Mac OS X browser shortcut, so I can just pop back to where I was. Okay, so save. So this is the client side of save. So I've got several sections here. The main action, this is the optimistic action, right? This is the thing that happens immediately as soon as the transact starts processing this transaction. And what I'm going to do is I'm just going to set the UI saving field to true. Over in the client, if we look for saving, all I'm doing is on this button, Semantic UI has a class you can add to a button, a loading class that'll make it look like a loading button. So I'm just saying, while saving, add the loading class. So that's all I've got to do to make the UI change. So over here, update UI saving on the item. I'm good. Remote true says this is a full stack op, and since I'm not modifying the parameters or anything in this remote section, I'm just saying send it like it is. I'll get the item ID and the diff in the server. The OK action, error action, I think are new in this video series. I may have mentioned them briefly in full stack mutations, but the OK action will happen when the remote finishes without an error, and the error action obviously will happen when there is an error. Now, one of the things we have to define here is what is an error. Let's hold off on that for a second and continue through this sequence of the happy path. So if it succeeds OK, then what I want to do is update the item in the database. Remember, we're normalized, so I'm going to a table entry, and I'm associating into that table entry new is false, so I'm making sure it's not marked as new still, and saving is false, so the spinner will stop on the button. Then I'm copying the entity's value into that pristine state, the form copy for that item, so that it won't look dirty at all. That row will just look clean. And again, well, not maybe again, the controls for save and undo are only visible when the thing's either new or it's dirty, and dirty returns true if and only if there's a difference between the values in the entity and the values saved in the form config. And this one works independent of current state, so that's why, I see, as I change these, if I put the E back, take the E away, put the E back, like it's detecting that, oh, well, now there's no reason to save it, right? There's no code I had to write for that. It's purely declarative. If the thing's dirty, show the stuff. If the thing's not dirty, don't show the stuff. And I've got a copy of it. So same thing here. I can completely modify this stuff, and that's also why I get the undo, right? I can copy pristine back to the entity. Okay, so this one's new, so it doesn't matter what I do to this one. It's going to be showing these row actions until I either say undo to remove the row or save. All right. So if I do hit save now, I'm going to get remote true. It's going to do this OK action. It's going to, when it gets a return. So let's see this sequence on the client side. So again, on the server side, I've got a 500 millisecond delay. I'm going to go to the network tab of Fulcro here, hit save. You see that in the transactions, there was a try save, and then there was a save, and on the network, there was a save. The save got the diff that had all the stuff in it. Notice the temp IDs. And then the return value of this has the item ID that was assigned, and then this is a special key, temp IDs. This tells Fulcro that anything in the app database that has this value, this temp ID value, should be remapped to that value. So this is part of Fulcro's support for the temp IDs I was mentioning. So imagine you've got an SQL database, you send this new thing across, it can detect, oh, that's a temp ID, I'll go and insert that because it's new, and then I'll ask the database what ID assigned it, and then I can tell the client what that number is. So let's do this again and show the effect of that. So this is kind of an automatic thing you don't have to think about. So I add a row, it gets a temp ID. I put data in the row, I save. Now watch during the save. I'm not sure why that one. Oh, this is a Fulcro inspect issue. It actually remapped the value and you see the thing now has value 1. Fulcro Inspect, this tool down here at the bottom, actually has to send values across a connection, basically, because there are different security areas of the browser, so the inspect tool can't read the actual state database. So what we're doing is sending a delta from app state to here to display this really approximation of the database. So the remapping happened, but unfortunately there's a little bug in inspect, I think. So if we see over here, or rather yeah, we got the right thing. It's got ID 4. If I go and look on the server in the item database, I'll see it got ID 4, got assigned ID 4, and in the state, if I go look at the just to verify this, the what do we call it? Root list. Oh, right, component by ID. This list, you notice the idents are all correct too. So item 1, 2, 3, 4. This was the one that had the temp ID. If I add another one, you see the temp ID in here. Yeah, hopefully we'll get a remapping that doesn't get corrupted by that transmission, and you see it remaps to 5. So these are just like inspect little issues here, unfortunately. So that's how temp IDs work. So really, you've seen all of the client code at this point for save. There's a little bit of error handling here to set saving false, but doesn't change new. And we'll talk about triggering that here in just a second. But let's go look at the server. So what the server needs to do for saving is it needs to look and see if the thing's new. So it looks at the ID that it received and figures out, well, if that's a temp ID, then the thing's new. And so what I need to do is figure out what the next ID is going to be, which you could do optimistically at the database level, or you could figure it out after the database insert. I'm doing it here. I'm doing it here. And if there's a category ID coming in, we need to fix that up. The item categories come across in the diff as an ident, and so we need to pull that out as a category ID. So if we find one, then we need to remap it so it'll be in our correct database format. So I'm basically just munging data here to get it to match my pretend database format. Then I've got a sleep 500, and then if it's new, I'm associating it into my database. If it's not new, I'm updating my database, and then I'm returning my real ID all the time, and then if it was new, a temp ID remap. That's really all there is to it. And of course now I can reload this and all of my rows should be there. And now of course I can change these, I can undo those. Undo should be working there. Wasn't undo working? It was, now it's not. Sorry, I've got another issue, but live demos like this often go awry in slight ways. So that's what that looks like. Now the other thing that I wanted to talk about in this video is what this sort of save might look like in SQL, because I think a lot of people don't really think through how cleanly this kind of thing can be, how cleanly done this kind of thing can be. So I'm going to for some reason my undo wasn't working there, so I'll maybe glance at that. But the thing that I really want to show as the kind of tie up to this, I'll need to stop my REPL here and refresh my deps, make sure dev is checked. And if you look at my deps, what I've added here is an H2 database, which is a pure Java database that's SQL compatible, that can run in memory, completely in memory, and the nice Clojure Java JDBC library, which lets me play with SQL databases in a nice, easy way. So I'm going to restart my REPL here, and I want to talk a little bit about this save just in terms of data. Okay, so the way we can define a database in H2 and with Clojure JDBC is I can just say this is DB type H2 mem, which Clojure JDBC supports, and the DB name is demo. All right, so there's my database spec. And then I can do things like create table, create another table. So I'm creating a category table that has an integer ID and varchar name. Then I'm creating an item table that has an ID that's an int, title that's varchar, price that's decimal. When you use decimal with H2, Java JDBC automatically knows to use big decimals to pull it in and push it out. In stock's an int, defaults to 0, category ID is an int that references category ID. This is a very common naming convention, category underscore ID, when you have a kind of a 2-1 relation, you know, from A to B. So I can insert a couple of categories in my database, and notice I can do this by map. I can just name the columns with keywords, values the correct types. There's a second one. I can throw a wrench in here. And notice I do have to use underscores to match the underscores in SQL because I don't have hyphens. So I'll insert a wrench with category ID 1. Oh, right. Yeah, see, I force assigned these an ID, so it didn't return me an ID. I did not force assign this an ID, so you see it's returning me an ID, which I could have figured out as a temp ID remap, for example, and insert that. So if I go down here and run a query with a join, right? Select title, price, ID, category ID, name, left join. This, you can imagine, with just some very minor transforms, can be turned into exactly what you'd need to return from item resolver, right? You basically just need to munge these up and turn anything that's snake case into hyphen case, or kebab case, I guess it's called, and add item to the namespaces of the things. That's a really easy transform, and so hopefully you can see that you know, query straightforward. Now I've written a couple of functions. I've got this ID key to join column that can take me from, you know, item category / ID to, oh, well, that's item underscore category underscore ID or something like that. I've got something that can take me to snake case on a key. So if I had like in stock or QTY in stock, right? These are just letting me go from Clojure convention names. There's a library for this as well, but I just wrote them real quick. And so ultimately, this is what a diff looks like coming from this application we've just built, right? So if I changed a category, I might get a category name. If I'm associating an item with a category, I'll get an ident here. That's the kind of thing I'll get. Update in Java in JDBC lets me say these things via maps as well. So I can do an update on this guy and say, oh, well, that's an adjustable wrench, and do a query, it's updated to adjustable wrench. I could say, oh, you know what, its price is supposed to be $11.99 big decimal, and ask for it, $11.99. So because this interaction, the same thing with Datomic, right? Datomic lets you do these kinds of updates with just regular maps of data structures. If we have some function that can convert that to a sequence of arguments to updates, right? So basically, what I need to do to actually affect these updates to my real database is say JDBC update bang on the database on some table, for example, item, and then the changes. Title, new title, price 32M. Well, that's exactly what I've got this function returning, right? These are my arguments to an update. So if I write a function like this, I can get something that then I can just do a doseek over. And then I can use Clojure's apply on JDBC update to do those updates. And now I can go up here and run my query, and I should see my updated things. Well, I should have seen my updated things. New name, new title. Oh, 22. There is no 22 in this database. Yeah, there we go. So you get the idea. So this is what I was talking about in an earlier video in terms of what diff hands you is pretty easy to transform. And just to take the point a little further, this is the grand total of code that I wrote to generate something that can then be applied to quite a lot of diffs. It doesn't quite work out for SQL for everything because you have in too many relations you have reverse keys, so there's a little more work there to do, but hopefully that gives you a general impression of how little code you can write to essentially get form save all the way through your application.